The moon, the planets, the stars and the galaxies in our night sky are all very far away. The distance to our nearest neighbor in space, the moon, was estimated almost 2,300 years ago by the Greek scientist Aristarchus of Samos. Aristarchus knew that if the length of the moon's orbit and the orbital period was determined, he was able to determine how far away the moon was. The orbital period was easily determined by timing the period from one full moon to the next. The orbital length, however, proved to be more taxing to determine. The moon's true size was unknown, but on the night sky, the moon's size could be measured. However, it was impossible to tell if the moon was large and far away or small and close to the Earth. The moon covers about 0.5 degrees of the night sky's 180 degrees that is observable from horizon to horizon. The ancient Greeks knew that a lunar eclipse was caused by the moon entering the Earth's shadow. Aristarchus thought that the shadow had the same size as the Earth. When the moon moved through the Earth's shadow at a constant speed, the size of the Earth could be determined. Aristarchus determined the Earth's diameter to be equivalent of 2 degrees on the night sky. With that knowledge, the moon's orbital length could be measured in Earth diameters. With that, the radius of the orbit was determined to be around 20 Earth diameters. The method Aristarchus used was good, but riddled with uncertainties. The value of pi had yet to be determined. The Earth's diameter was unknown, and so was the size of the Earth's shadow at the distance of the moon's orbit. Ptolemy used a similar method 400 years later and determined the distance to the moon to be 64 Earth radius when the distance was greatest. With the Apollo missions in the 60s, it became necessary to determine the distance to the moon very precisely. The trigonometric measurements that had been used since the ancient Greeks were too inaccurate, so a new method was developed. Series of powerful radio signals were sent to the moon, and the period to the echo was detected. Radio waves travel at a constant speed, the speed of light, and by knowing how long the period the radio waves had spent traveling from the Earth to the moon, the distance could be determined with a very high degree of precision. An average distance of 236,000 miles was measured with the precision of less than a mile. Thanks for watching Godric Science Channel. Remember to subscribe so you don't miss out on an update. Please write a comment below and please let me know what new subjects you would like to see explained. Follow Godric on Twitter, Instagram, Facebook and Pinterest. The links are in the description.